Hello students, you are welcome to the GMAT 41's chemistry class. In our class today, I'll be teaching you about relative atomic mass, relative molecular mass, the mole, and also percentage by mass of an element in a compound. You recall that in our previous class, we defined various terms like atoms, elements, molecules, and ions. So now we're going to see what the relative atomic mass of an element is, the relative molecular mass of an element or a compound. We'll talk about the moles. We'll also talk about the percentage by mass of an element in a given compound. We'll also look at how we can determine these things by calculation. So first, what is relative atomic mass? R.A.M. Now I want to say this quickly. When talking about relative atomic mass or relative molecular mass, what we are interested in is simply to compare how heavy a particular element is compared to another one. The another one there is carbon. We usually compare the weight of other elements to that of carbon. Does that make sense? So with this idea, when we define what relative atomic mass is and relative molecular mass, it will make more sense. Don't forget, we are trying to compare the weight of elements, the weight of compounds, with that of carbon. Coming to that of carbon is only 1/12 of that of the weight of carbon that we want to make that comparison with. So, what is relative atomic mass? By definition, it is defined as the number of times the average mass of one atom of the element is heavier than 1/12 the mass of one atom of carbon-12. Now, you would recall that we talked about the first 20 elements, their atomic numbers, and of course, what we call their mass numbers. Their mass numbers, the value is also the same as the relative atomic mass of their element. So, carbon-12, the mass of carbon is 12 grams. Alright? So when you compare the number of times the mass of one atom of an element is heavier than 1/12 the mass of one atom of carbon, then you are simply trying to get the relative atomic mass of that element. When we talk about 1/12, 1/12 is simply 1/12. Okay? Alright, now, the relative atomic mass of an element is measured using an instrument known as the mass spectrometer. Mass spectrometer. Although we can also calculate relative atomic mass of an element. If we want to calculate it, there is something we use. We call that the percentage abundance of the isotopes of the element. Once again, the percentage abundance of the isotopes of the element. We can use this percentage abundance to calculate the relative atomic mass of an element. But don't worry yourself about that. In our next class, we would talk about these isotopes. Is that okay? And how we can calculate the relative atomic mass of an element from the isotopes of that element. Until then, for now, just know that we can measure the relative atomic mass of an element using an instrument known as mass spectrometer. Now, let us talk about relative molecular mass, this time of an element or a compound. Remember, from our previous class when we defined an atom, we said an atom is a part of an element that can take part in a chemical reaction. Then a molecule, we define it as part of a substance. That substance can either be an element or it can be a compound. So you now see the difference between atom and molecule. When talking about atom, it is simply part of an element. But if you talk about molecule, it's part of a substance. That substance can either be an element or what? A compound. Not just an element, okay? Now, if you're defining relative molecular mass, the definition is similar to relative atomic mass. If you look at these two definitions, the difference is just that you're talking about atom here, and then you're talking about what? Molecule. So how do we define relative molecular mass? It is simply the number of times the average mass of one molecule, take note of that now, one what? Molecule, is heavier than 1/12 the mass of one atom of carbon-12. The number of times the average mass of one molecule is heavier than 1/12 the mass of one atom of carbon. Relative molecular mass can also be referred to as formula mass, although formula mass is a general word we use for them. Because when we talk about relative molecular mass, it's simply mass of a molecule. But then you can still use formula mass to refer to it. Only that formula mass can also refer to mass of an ion, mass of a radical, or even mass of an electron, or other groups. But in case you hear something about formula mass, please, it's still a term used to refer to relative molecular mass. Next, I'll be teaching you how we can calculate the relative molecular mass of a compound using the relative atomic mass of the atoms, the elements that make up the compound. If I give you a compound and ask you to determine, to calculate the relative molecular mass of that compound, that is the number of times the average mass of one molecule of that compound is heavier than 1/12 the mass of one atom of carbon-12, what would you do? How do you determine, how do you calculate the relative molecular mass of that compound? So that is what I'll be talking about in this video. Now I've given you a short note to tell you what you need to do. All you need to do is simple. To calculate the relative molecular mass of a compound, simply multiply the relative atomic mass of each element in the compound by its atomicity. Atomicity there means by the number of atoms of that element in the given compound. Once you do this, add up everything. What you get is the relative molecular mass of that compound. A quick example will help us to understand this better. And that is why we have our very first question here. Question number 1. Calculate the R.M.M, that is relative molecular mass of calcium trioxocarbonate 4. Relative molecular mass of calcium trioxocarbonate 4. To get the relative molecular mass of calcium trioxocarbonate 4, you should know how to write calcium trioxocarbonate 4 in the first place, because the chemical formula of calcium trioxocarbonate 4 was not given to us in the question. Now, in our previous classes, we've already treated how to write the chemical formula of compounds, the correct chemical formula of compounds. So if you hear calcium trioxocarbonate 4, now which elements did you hear while I was pronouncing this compound? You heard calcium, you heard oxo. That tri simply means tree, Latin word for tree, so it's a number. Okay, the elements you heard are calcium, oxo. That oxo there is oxygen. Then you heard carbonate. That carbonate there is carbon. Now that trioxo simply means there are 3 atoms of oxygen there. So calcium trioxocarbonate 4 is written like this. Calcium, you write the first element whose name you heard. Trioxo, that oxo, you don't write it next. Carbonate, that is carbon is the next one you will write first before the trioxo. That trioxo means oxygen, 3 atoms. This is the correct chemical formula of calcium trioxocarbonate 4. When I taught you radicals, we explained that the trioxocarbonate is CO3 2-. Then if you have calcium, the valency of calcium is 2 plus. When they interchange, you get calcium, then CO3. Okay, that is not what we are learning here. Our interest is to see how we calculate the relative molecular mass of calcium trioxocarbonate 4. So let us do that quickly. You see that here they gave us the relative atomic mass of the elements that make up this compound. Calcium, the relative atomic mass is 40. Carbon is 12. Oxygen is 16. So we are going to come here and say that R.M.M, relative molecular mass of this calcium trioxocarbonate 4, will now be equal to, I'll come to this. How many calcium atoms do we have in this compound? Only one. Remember, invisible one here. So you're going to put 40 for that. Remember, we said you have to multiply the relative atomic mass of each element by its atomicity. How many atoms of calcium do we have? We said 1. Alright? Then plus. Alright, permit me to use a Bill marker to represent the atomicity. That's 1. Then go to carbon. We have 1 atom of carbon in this compound. And the relative atomic mass of carbon is 12. So it's going to be 12 times 1 atom, which is 1. And then lastly, we go to oxygen. Plus oxygen, its relative atomic mass is 16. So we go, that of oxygen is 16, so I'm going to multiply it. How many atoms of oxygen do we have in this calcium trioxocarbonate 4? 3 of them. So it's going to be times 3. Therefore, the relative molecular mass of calcium trioxocarbonate 4 will now give us 40 times 1, which is 40, plus 12 times 1, which is 12, plus 16 times 3 is 48. Okay, so let me conclude here. Therefore, relative molecular mass of calcium trioxocarbonate 4 is equal to, if you add up this, 40 plus 12 will give us 52. 52 plus 48 will give us 100. 100. This is our answer, the relative molecular mass of calcium trioxocarbonate 4. Please take note of this. You can put it down. Relative molecular mass of a compound does not have any units. So don't go put gram here. No, you don't do that. We'll still talk about the one that has that unit, gram. That is molar mass. Is that okay? If it is molar mass that we are calculating, then we'll put gram per mole. But this, we don't put any unit. In this video, we are going to obtain the relative molecular mass of tetraoxosulfate 6. Question number 2 here, right? And then also, we are going to calculate the relative molecular mass of CO2. This CO2 is called chlorine molecule. Chlorine molecule. Remember, we have Cl. Cl alone is chlorine atom. Chlorine is diatomic gas. Diatomic gas. So it usually exists as 2 atoms, alright, making up 1 molecule. So we're going to get the relative molecular mass as well too. How do we do this? We've already solved question 1, and we're going to use the same knowledge to solve this problem. Alright, solution. Going to solve here. Number 2. What is the relative molecular mass of tetraoxosulfate 6 acid? Tetraoxosulfate 6 acid. We're given the relative atomic mass of the elements that made it up. Now, listen as I pronounce it again. Tetraoxosulfate 6 acid. Now, you heard something like oxo. That tetra is a Latin word for 4. It's a number, so it's not an atom, okay? The atoms you heard are oxo and sulfate. That sulfate is the same as sulfur. Okay, does that mean that we have only 2 elements in tetraoxosulfate 6 acid? The answer is no. Whenever you hear acid, it means there is hydrogen in it. Is that okay? There is hydrogen. So actually tetraoxosulfate 6 is hydrogen and the tetraoxosulfate ion. Remember the tetraoxosulfate ion, we've already treated something like that under valencies, you know, in our past classes. SO4 2 minus. Of course, if it reacts with hydrogen, hydrogen is positive like this, you know. their valencies will interchange. So tetraoxosulfate 6 is H2SO4, tetraoxosulfate 6. You had oxo, you had sulfate, that's sulfur and oxygen. Now acid shows that there is hydrogen there. Take note of that because you are going to work on an assignment where you will determine the relative molecular mass of an acid known as trioxonitrate 5. And I wouldn't write the compound for you, I would not. Let's see how it goes. To calculate the relative molecular mass, we said you're going to multiply the relative atomic mass of each element by the number of atoms there are in the compound. Starting with hydrogen, relative atomic mass of one atom of hydrogen is 1. Then you multiply it by the atomicity. How many atoms is hydrogen in this acid? 2 atoms, you can see that. So I'll put it there. Now we are going to add it to the relative atomic mass of sulfur multiplied by its atomicity. Relative atomic mass of sulfur is 32. So it's going to be 32 times, how many atoms of sulfur do we have here? 1. And then lastly, plus relative atomic mass of oxygen is 16. 1 atom of oxygen. But how many do we have here? 4. So it's going to be 16 times 4. 16 times 4. The atomicity is 4. So I wrote the atomicity with blue marker. So we're going to work this out and see what it will give to us. 1 times 2 is 2 plus 32 times 1 is 32 plus 16 times 4. 16 times 4 will give us 64. 64, you know, 6 times 4 times 6 is 24. Write 4, carry 2. 4 times 1 is 4 plus the 2 is 6. So if you work out this, therefore, the relative molecular mass of tetraoxosulfate 6, H2SO4, will be equal to 2 plus 32 will give us 34. 34 plus 64 will give us 98. So I'm going to put 98, and that is our answer. Very simple, right? Let us move on to the second one. We have to calculate the relative molecular mass of chlorine molecule. So question number 2, number 3 rather. Chlorine molecule. Relative molecular mass of chlorine molecule. What do we do? It's simply going to be relative atomic mass of 1 atom of chlorine, which is given here 35.5. Then how many atoms of chlorine do we have here? 2. So it's simply going to be 35.5. Then we will multiply it by 2 times 2. So if you work in this, therefore, the relative molecular mass of chlorine molecule will be equal to, if you multiply this, 2 times 5 will give us 10, right? 0 carry 1. 2 times this 5, put your point here, you get 10 plus the 1, you add that, then 2 times 3 is 6. 6 plus the 1 will give us 7. So this is 71, please. Alright, 71. So looking at this, what do you think would be the relative molecular mass of oxygen molecule, O2? O2 is going to be relative atomic mass of oxygen, which is 16, times what? 2. You get 32. So why the relative atomic mass of oxygen atom is 16? That of oxygen molecule is what? 32, because oxygen molecule is O2. Next, we are going to treat molar mass of a compound.